Liquid hot metal is cast from a blast furnace. The hot sequences of steel production start. Steel is one of the most important materials in the global economy and is being continuously developed in order to meet the growing demands of the processing industries. Salzgitter AG, the second largest producer of steel in Germany, has specialized at its Salzgitter works, amongst other products, in coated sheets and large tubes, characterized by state-of-the-art material properties. Outstanding quality and economical viability on the global market only can be achieved through perfectly reproducing production processes. Modern and reliable weighing technologies are essential to this. This film presents a weighing system that creates a process data window on the transport route between blast furnace and steel plant. So let's follow the path taken by hot metal at Salzgitter Flachstahl. From below the blast furnace, it flows straight into torpedo cars. They leave the casting bay as trains with up to 3 cars and are driven into a so-called withdrawal track. At its end, the train passes a crossing and changes track and direction. After about 1 kilometer on the journey back, it reaches the point where the hot metal is passed over to the steel plant. Here, the material is fed into the converter and afterwards processed into crude steel. In 2007, Schenck Process installed and commissioned a modern multi-rail hot metal weight scale in this track section. This new dynamic weighing system automatically determines both the gross weight of all loaded and the empty weights of the returning torpedo cars as they travel along the railway. Integrated inside the track, the weighing system is around 11 meters long, and here you can see it already operating in fully automatic mode. Let's check out the benefits that weighing hot metal halfway between blast furnace and melt shop brings to these 2 key steel production units. First of all, this weighing system offers the blast furnace operations a much better degree of knowledge in the form of extra process data. All around the globe, many blast furnaces still use technical models of the burden and coke input to calculate their production output. The results vary considerably depending on the quality of these models. In contrast, multi-rail weighs the produced hot metal directly in a reproducible process with a very low error of only ±0.5%. In this way, the new railway scale allows blast furnace management to record and monitor the actual masses of hot metal produced per tap for the first time ever. Furthermore, the effects of steps taken to improve the process technology can now be quantified, which is key to future investment decisions. The steel plant also benefits from the new scale during the preparation of the next converter charge, as at the moment, the hot metal input can usually only be weighed by the melt shop crane scales rather late in the process. Due to its installation position, the new weighing system provides the incoming weights much earlier, enabling significant converter process control optimization. Finally, the maintenance department uses the weighing data as well to systematically monitor the condition of the fireproof brick lining inside the cars. If the weights of the full wagons increase and the empty weights decrease over time, this indicates that the brick lining is being significantly worn. In contrast, rising empty weights are a sign of solidified skulls building up inside the torpedo cars. To make these analyses, an individual diagram is produced for each car, specifying first the critical weight limits. and secondly, an average empirical curve for typical time-dependent variation between the empty and full weights. Comparing these reference data with the actual weight readings allows critical changes in the car's brick lining as they continuously occur in operation to be detected and assessed. In this regard, the weighing data are also key to optimizing maintenance intervals and process safety. Let's now take a look at the weighing technologies that make these various benefits possible. At the heart of every modern and accurate scale offering long-term reliability are sensors perfectly matched to the specific requirements. They transmit all applied forces to the ground and measure the vertical forces during any kind of loading without distortion. In this multi-rail application, the load cells are integrated inside the track's conventional concrete sleepers as a stable rail fixation element. Development and manufacturing of these load cells, as well as assembly and testing of the complete weighing sleepers, are one of the core competencies of Schenck process. Our lengthy and proven experience in the design of strain gauge sensors and railway scales guarantees users state-of-the-art systems with a long service life. The high-tech weighing sleepers and the integrated load cells are very accurate. Their design and load capacity identical to the standard concrete sleepers installed in the rest of the railway. This innovative adaptation brings considerable benefits during subsequent installation work at the site. Once all in-house quality checks are completed, the modular weighing system is very easy to load, requires little space, and can be cheaply shipped anywhere in the world from the Schenck process facilities. In the meantime, at the installation site, preparations for mounting the weighing sleepers are already well underway. In Salzgitter, this was part of a major track modification. For other customer projects, existing sleepers inside the chosen track section can be directly replaced with the new weighing sleepers. The high axle loads of the torpedo cars mean that it is very important for sufficient ground load capacity to be generated and ensured below the railway, regardless of whether the concerned track section contains a weighing system or not. At Salzgitter, as is standard practice for all heavily loaded railways, we first inserted and compacted a so-called planum protection layer to generate this strength and protect the ballast from dirt. In the next installation step, the multi-rail sleepers are positioned and aligned on an initial layer of ballast. During this work, and also during the subsequent rail fixation and welding, staff at the site need hardly concern themselves with the integrated weighing sensors. In this manner, the robust and simple multi-rail technology can be installed very quickly, minimizing the required track downtime. Furthermore, the system is designed without any rail gap between the external track and weighing area, something that in the past represented a critical mechanical interface, always subject to heavy wear and often damaged. Once the weighing track has been filled up with a second layer of ballast, the scale can hardly be seen anymore. This isn't a problem, because the next step of tamping the entire track again is of no concern to the new weighing system. Straight after electrical commissioning, a calibration car with a known weight is positioned on the scale to calibrate the weighing system statically. The customer does not need to provide an approved static reference scale for this electrical adjustment. This again makes the system very cost-effective for the final user. Once all installation work is completed, the new railway scale consists firstly of the weighing sleepers. Additional force sensors measure the forces bypassing the scale through the continuous rail. The cables of the various load cells are collected in a field housing close to the track. Additionally, a tag reader detects the identification numbers of the passing cars in fully automatic mode. The system is completed by the scale electronics and a service PC located inside a weighing container. In normal operation, automatic mode does not require a scale operator, as the field data transfer already forms part of the entire solution. Based on the dynamic bogie weighing principle, multi-rail hot metal weight achieves an accuracy of up to plus/minus 0.5% of the weighing range for a passage speed of between 4 and 8 kilometers per hour. After each passage, a fiber optic cable transmits the results to a second PC installed in the blast furnace control room, which straight away prints out a clear weighing report containing the following data: gross weight of every car, passage speed, passage direction, identification numbers of the torpedo cars, and weighing status. All these weighing data are stored in the software package Dieselware Terra for further processing. In addition, the service package PASS delivers sophisticated remote maintenance functions to guarantee maximum system availability. Given this modular structure, Schenck Process requires only little information to plan a new multi-rail hot metal weight system. We basically need to know the axle distances of all cars and engines, and their tare and gross weights. These data are used to design a weighing solution optimally adapted to the site conditions, ensuring an extremely fast and cost-effective installation. In this basic study, we also define the length of the so-called weighing area, depending on the train composition. This even and undisturbed area before and after the scale center allows the train to pass smoothly, which is a key to high dynamic weighing accuracy. Every day, the modern high-accuracy scale in Salzgitter weighs 14,000 tons of hot metal from 3 blast furnaces. With this reference, Schenck Process has proven that dynamic rail weighing systems featuring technology that is superior to conventional weigh bridges in all respects can be realized at virtually no extra cost in terms of railway construction. As conventional weigh bridges need costly foundations, heavy torpedo scales based on the multi-rail hot metal weight principle offer great potential even during short track modernizations. Let's therefore summarize the main benefits again. The multi-rail technology is also being successfully installed in other applications. For instance, for the dynamic, legal-for-trade weighing of iron ore wagons entering the steelworks. Besides, our weighing technology can also be integrated inside the supporting structure of new torpedo cars. As a team with more than 25 offices around the world, Schenck Process will work extensively with you to also make the various functions of multi-rail technology for blast furnace, steel plant, and maintenance beneficial for your plant, and this way further optimizing the quality, costs, and reliability of your production process. Multi-rail hot metal weight. Schenck Process. We make processes work. www.schenkprocess.com